Hi, welcome back. This is Math 0955, and we're working with plotting points today. So we'll introduce the Cartesian coordinate system, which I believe is named after Descartes. And so the first type of problem we see, on the left there, you have a graph, some graph paper with a bunch of little boxes on it. And then there's a point you want to plot. And the point 5, 6. The first coordinate is called the x-coordinate, and I'll tell you whether you're going left or right. Let's put some tick marks on here for distances. Then the second coordinate of the ordered pair is the 6, and I'll tell you if you're going up or down. So you start with the 5, and that basically means go to the right by 5. So you go and you go to the tick marks and count 1, 2, 3, 4, 5. So you're sitting right there with that blue point. And then you're going to go up 6. So you go up one. I probably need one more point here. So let me put another tick mark on there. So then I'll put it in purple. We're going up 1, 2, 3, 4, 5, 6. So the official point that you would plot would be this point right here. And it doesn't have to be that big, obviously, but okay. So on the graph, you're just going to move the dot that's kind of surrounded in yellow and has a blue box around it. So you go over 5, 1, 2, 3, 4, 5. And you may need to zoom in a bit, and then go up 6. So 1, 2, 3, 4, 5, 6. Okay, and then check your answer. Okay, good. The second part then is to identify the quadrant. So the quadrants are labeled in a counterclockwise fashion. So start in the first quadrant there, I just marked it, and then the second quadrant, and then go down to the third quadrant, and then go back right to get to the fourth quadrant. So this point is located in the first quadrant. And we're using Roman numerals. In the software, it looks like an I. So just click on that and check your answer. Yay. Okay, if the number is negative, instead of going right or going up, you're going to go left or you're going to go down. So so this is question 1. In question 2, the first coordinate is negative. So that means you're going to go to the left. And then the 8 means we're going to go up. So let me put some tick marks on here. I usually, personally, I don't really label the tick marks. You don't really need to unless your tick marks aren't going by ones. So if your tick marks are like going 2, 4, 6, 8, you're not necessarily going to need to tell me what they are. So anyways, the point we want to plot -1, 8. So we go to the left, -1. So I go in that direction, -1. So I start at the origin, the middle, 0, 0, and then I go to the left, -1. And then I'm going to go up 8. So +8 means go up 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I'm going to mark that with a black dot. And of course, in the software, you just move over 1 and then go up 8. And then you want to identify which quadrant it's in. And we usually don't, literally write 1, 2, 3, 4 in for the quadrants. You could just note it's in the second quadrant. So quadrant 2. And then you could click on the appropriate answer. You can also be on the x-axis. So the horizontal line here is the x-axis, and usually they'll designate that by putting an X on that line. And then the y-axis is the vertical line that you see there. So horizontal is like the horizon. If you're looking out at the ocean or something, that straight line, the horizon. And then a vertical line, like a vertical jump in basketball, it's up and down. So anyways, what do we have? Second quadrant, quadrant 2. Just go over there and check the answer. Yay. Okay. This one, -6, -5. So that means you're definitely going left, and then down. Okay, so I put some tick mark 1, 2, 3, 4, 5, 6. I'll just put 6 on each arm. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And the point I want is -6, -5. So I go to the left by -6, and now I'm going to go down because it's a negative number. So left 1, 2, 3, 4, 5, 6. And then I'm going to go down 1, 2, 3, 4, 5. A little easier with the graph paper, but hopefully you get the idea here. And then it's quadrant 3. Okay, so great. Let's just go on to the next one. Yes. So this is one where you kind of have to graph in between the tick marks with 3, -1.5. So problem 4 here. Let's put some tick marks on there. 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So we'll have 3 and then -1.5. So I'm going to the right by 3 because that's positive. And then I'm going to go down -1.5. Maybe I should label some of these just for the sake of, showing it to you at least once. So going to the right, that's the positive x-axis. And you see positive numbers. And then going up, that's the positive y-axis. And then going to the left, that's the negative x-axis, and there you're going to put negative numbers on your number line. And then going down, that's the negative y-axis, and again, you'll use negative numbers on that arm. Okay, so anyways, 3, so I go over 1, 2, 3 here, and then I go down -1.5, so that's right in between -1 and -2. Okay, so I'll label that dot. That's in the fourth quadrant. On the in the software, you're probably going to have to zoom in a bit, and you can see their tick marks aren't really going by ones here, right? But anyways, we have to go to the right by 3, so there's 3, and then go down 1.5. So there's 1, and then another half for the 0.5. Okay, and of course that's quadrant 4. Yay. All right, -1, -1. Okay, I think we can handle that one. So it's just going to the left and then going down. 8, 0. So this one will be on the x axis as opposed to one of the quadrants. So again, I want to plot 8, 0, and the xy plane here, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is my x-axis, my y-axis. So I'm going to go to the right by 8, and then you don't move at all in the vertical direction. So I go 1, 2, 3, 4, 5, 6, 7, 8, and then you just stay right there. Okay, and it's on the x-axis. So it would probably, okay, so you have to go to the right by 8. I don't look like it's really on 8. So you may have to zoom in every once in a while and make sure you hit it. 6, 7, 8. That'll work. And then, does it want anything else? Okay, apparently not. 0, 4, that'll be on the y-axis then. So you don't move in the x direction, and then you go up by 4. Okay. Yes. 0, -6, so that's going to be on your y-axis again. So 0, -6. So just put a couple tick marks on these guys. And then I'm going to go down 1, 2, 3, 4, 5, 6. So in the horizontal direction, you don't move. So that 0, the first coordinate there, there's nothing to do. It's just stay there. So I'm at the origin, and then the -6, that means to go down -6. So go 1, 2, 3, 4, 5, -6, and there's going to be my point, and it's on the, so this is the x-axis, this is the y-axis. if it asks. Sometimes it won't ask. Okay. Yep. Okie dokie. So we have some plotting fractions. Whenever I plot fractions, I usually convert to a decimal first. So we got the 0.9 halves, comma 3 halves. So I'm going to convert that into 4.5 and then 1.5. So here I'm on in the XY plane 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I just look at the bigger number between the two coordinates. So 4.5 is the bigger number, and that tells me I kind of need probably to put 5 tick marks on all the arms of the XY plane here. So anyways, I'm going to have to go to the right by 4.5 and then go up 1.5. So to the right, and these are going by ones. And this will be 2. Whoops. Okay. So you don't have to label everything. You just need to be able to communicate kind of what these tick marks represent in certain circumstances. So anyways, I'm going to the right 4.5, 1, 2, 3, 4.5 is bar here, and then I'm going up 1.5. So that would be the official location of the point. But the idea is to convert your fractions into decimal form. So anyways, 1, 2, 3, 4.5, and then you're going to go up. There's 1, and then another 0.5. Okay. Same deal for this guy. So you just convert the 7 halves to a decimal. 0, 0 is located. You don't move at all, right? And you're always, if it didn't make that clear, you're always kind of starting your journey at the origin. So the origin is this point right at where you don't move, where you start. That's 0, 0, which is called the origin. Okay. So 0, 0 is the origin. Yes. Okay. Want us to plot 0, negative 1/2, so that's just don't move and then go down by 0.5. Go down by 0.5. Give the ordered pair that corresponds to the points shown. Okay, so they give you a graph of a point, and then you got to figure out the coordinates. So problem 13, you just count over, you start at the origin, right? And then you're just going to count over 1, 2, 3. So the x-coordinate is 3. So you go until you're right underneath or over top the point, and then count up or down to where you need to go. So in this case, we're counting up. And so the ordered pair should be 3, 1. I think you got to put the parentheses and everything in there. Let's see. Yeah. Okay. Same deal for this guy. That would be negative 3, 5, I think. So you just got to count. Be careful. 1, 2, 3, 4, and then down negative 5. So that'd be negative 4. Yeah. And then negative 5. Okay. More of the same. Just counting over to the point. These are kind of challenge question. So number 17. In which quadrant are the y coordinates positive? So what you can do if you're not sure is kind of just pick a point in each quadrant and look at the signs of the coordinates. Okay, so if you look at the point 2, 1, both of its coordinates are positive. So we can kind of write that in the first quadrant. So let's over to the, maybe to the side here, do kind of a picture. So in the first quadrant, both coordinates are positive. Okay, and the second quadrant, let's look at maybe negative 1, 2, positive 2. Right, so there's negative 2, 2. So all the points in that second quadrant are going to have the form negative and then positive. Okay? And what about the third quadrant? So you go over negative 1, negative 2, negative 3, negative 1. So in that quadrant, both coordinates are negative. And then the fourth quadrant, let's go over 1, then go down 1, 2. So that'd be 1, -2. And that quadrant, it's going to go plus and then negative. Okay. So the question's asking, in which quadrants are the y coordinates positive? Well, that's just going to be quadrant 1 and then quadrant 2. So you have to check both of those. Yay. Okay. And then which quadrants do the x coordinates and the y coordinates have the same sign? So the x coordinate and the y coordinate. So you need a plus plus or a minus minus is kind of how that you translate that question into English or maybe into math. First quadrant and then the third quadrant. Right? Okay, so this next set of problems, what you're kind of doing is a substitution, and then you're seeing if the equation is true or false. So in particular here, number 19, they give you an equation, y equals 7x, and then you're substituting in these ordered pairs and seeing if they work in that equation. Okay. They're kind of getting you set up for graphing eventually, graphing straight lines and stuff like that. Okay, so note each one of these ordered pairs has an x coordinate and a y coordinate. So it's always x comma y. That's in alphabetical order. And so in the formula, you're going to be substituting in 5 wherever you see x, and then 35 wherever you see y for the first coordinate. Okay? So you're going to put 35 in for y. Okay? That's you're putting 35 in that place where I just put the red box. And then that will equal 7 times x. And you're going to plug in 5 for x in this particular case. Okay. So then you simplify both sides. Don't do any kind of properties of equations where you're moving stuff to both sides or something. Just simplify both sides. And if it's a true statement, then it is a solution. Okay, so this coordinate is a solution. So I'll just write yes for lack of not wanting to have to, just because I don't want to have to write it all out. Okay, so in this case, yes, it is a solution, so you would just click on that is a solution. And then so on and so forth, right? So in the second coordinate, again, this is your x. You may want to write that above there just to remind yourself. So y is 35, and then I have 7 times 2. Simplifying, I have 35 equals 14. That does not work. Okay, so that is not a solution. And then finally, plugging in x and y here. So negative 42 for the y. I have 7 times negative 6. So it would be negative 42 equals negative 42. And that's certainly true, so that will be a big yes. So it is a solution. Okay. So it's really just kind of a plug and chug deal. Let's look at one maybe a little more work. So this is problem 21. They give us the equation y equals 5x plus 10. And I want to zip through again, the same question. Check these ordered pairs to see if they're solutions to the equation. Okay. Again, this is x, this is your y. So I'll have 10 equals 5 times x plus 10. So I have 10 equals 10. That is a solution. So yes. And they want you some sort of, okay, so it is a solution because y does equal 10 when x equals 0. The next guy, so you have 0 equals 5 times, again, this is x, this is y, negative 2 plus 10. So I have 0 equals negative 10 plus 10, and then that will work. Negative 10 plus 10 is 0, so that also is a solution. So you're looking for one that says it's a solution. So it's either A or B, and then it's a solution because y does equal 0 when x is negative 2. Yeah, yeah. Okay, and now let's check the last guy. So I have negative 12 equals 5 times 2. That's not going to work, right? So I got negative 12 equals 10 plus 10, and then negative 12 equals 20. So no can do. Where was that one? So it's not a solution, so it's either A or D. So y does not equal, well, that's not the case. Y equals negative 12 in this case, so it must be D. 2 negative 12 is not a solution because x does not equal negative 12 when y equals 2. That's not it, because y is equaling negative 12. Let me read that first one again. So A says 2 negative 12 is not a solution because y does not equal negative 12 when x is equal to 2. Yeah, that's probably what they want there. These are kind of a bit oddly worded. Let's read the other one again too. So 2 negative 12 is not a solution because x does not equal negative 12. So that's definitely not true. So the x, no. Okay, so it has to be A. And yay. Okay. This is just more of the same. Just kind of the format of the question is written differently. Here's one with fractions, so it's always interesting. Let's try number 23, sure. Let's get x plus 5y is 0. We want to try 0, 0. So plugging in, this is x, this is our y. So 0 plus 5 times 0 is 0. So you get 0 plus 5 times 0 is 0. And then 0 plus 0 is 0. So that works. That's a solution. Okay, let's go for one of the fractions now. So I have 1 comma 1/5. Right. So plug in 1 for x plus 5 times y is 1/5. That's not going to work. 5 times 1/5 is 1. 2 is definitely not 0, so that's a big no. It's not going to work. And then the last guy, so we have 9 comma negative 9/5. So plugging in 9 for x plus 5 times negative 9/5 equals 0. So we have 9 minus the 5 over 5, same as 1 over 1 times, so that will just be 9 equals 0. 9 minus 9 is 0. So that's a big, sorry, that's a big yes. So if it's a true statement, it is a solution. Okay, great. Let's see what else I have. This is more of the same. Oh, this one's a little different. This one is a little bit different because there's no y variable there. So for some reason that really makes people upset. But don't overthink this stuff. You just want to kind of think like you're a computer. So they want to know if 3 negative 8 is a solution. This is your x and this is your y. Okay, there is no y variable in the equation, so there's really nowhere to put the negative 8, and that's okay. All you're going to do then is plug 3 in for x. So I'll have 3 minus 3 on the left, and you figure out if that's 0. Yes, it is. So that must be a solution. So yes, I'm going to check. Okay. That's y. This one is negative 4, negative 4. So again, you're not really going to use that y coordinate. You're just going to plop in the negative 4 for x. And simplify. And that dude does not work. So you'll say no. Then is 3, 0 going to work? So you're plugging 3 in for x. 3 minus 3 is 0. So yeah, that one works. So pretty much anything, yes, with the first coordinate being 3 would work there. Okay. Oh, I'm not done. No, I didn't check it. Okay, these next ones are filling in charts and producing ordered pairs, and then eventually we'll plot the ordered pairs, and that will give us a visual picture of the given equation. Okay, so let's sorry, let's not do this one. Okay, sure, let's try this one. So you got to build a table. So number 26, y equals negative 11x. And you have x, you have this y equals negative 11x. And then they want you to write the ordered pair, x comma y, not x comma 2. And these are a little time consuming for us people who are terrible typists. I cannot type at all, so I feel your pain if you're in my boat. I'm going to go ahead and kind of fill in this stuff. Okay, and so to get the y equals negative 11x, you're taking the x equals negative 2 and plopping it into that formula. So we get y equals negative 11 times negative 2, and that's going to be a positive 22. So the resulting ordered pair is negative 2, 22. And then in the table in the software, you're going to put negative or positive 22 there. Okay, so you see how good of a typist I am. And then here you got to put in the ordered pair. So negative 2, 2, comma 22. And then we got to go through the whole table. It's kind of a bummer if you mess one up. It's kind of, you got to go back and check all your work. But anyways, the next guy, y equals negative 11 times x is negative 1. So that'll be positive 11. And the ordered pair, negative 11, negative 1, 11. Let me just do the table and then I'll fill it all in. This guy, negative 11 times 0. That's just going to be 0. So it's a 0, 0. Here, y is negative 11 times 1, which is negative 11. So that should be 1 comma negative 11. And then finally we have, and I'll just write negative 11 times 2. So just put the expression evaluated for x equals 2. So negative 22 there. And then my ordered pair is 2, negative 22. Okay, and then I got to go to my chart, fill it all in. And then plug this in. I'm using the tab button to move around inside the chart there. Check your answer. Hope it's right. And okay, so then you just keep on moseying on. This is just another chart problem, except you're doing one at a time. Another chart problem. Another chart problem. Let's try this one. It's problem 31. This time the equation y equals 5x plus 4. And in your table here, you're going to put the ordered pairs on the other side. And you're going negative 2, negative 1, 0, 1, 2. So you'll have, so you're using the equation to get the y coordinate. So you're plugging those x values into that expression in red. They're just boxed in red. So it's going to be 5 times negative 2 plus 4 for the y coordinate. Right? I don't want to put that parentheses there. Okay, so this will be negative 10 plus 4, which is negative 6. So the ordered pair at the end of the day is negative 2, negative 6. 2, negative 6. Okay, the next guy, 5, negative 1 plus 4. I mean, usually when I write it out, it's a bit redundant to have to rewrite the x, again. So I just kind of make it x on one side and y on the other. For whatever reason they're doing it like this in the software, I don't know. Seems to just be kind of a time waster, but okay. So 5 times 0 is 0 plus 4 is 4. And so 0, 4 would be the ordered pair. Oops, I skipped one. Negative 1, comma, what's this guy? Negative 5 plus 4 is negative 1. Okay, so that'd be negative 1, negative 1. Correct. Sorry. I was in the right place. Negative 1, negative 1. And then we have 0, 4. 4. And then we have 5 times 1 plus 4. That'll be 9. So this is 1,9. Make sure you don't accidentally put too many parentheses in there. It won't like that. 2, so 5 times 2 plus 4. 10 plus 4 is 14. Okay, so we have 2 comma 14. And then you hope they're all right. If not, usually it'll say one or more of your answers is incorrect. Okay, so now is the part that's kind of new in this section. They want you to take all of these ordered pairs and plot and form an equation of a line. Thankfully, you're not going to have to plot all the ordered pairs. All you basically got to do is pick 2 of them to plot, and then that'll be good enough. So, for example, if it was on a test, you'd have to write it all out and draw it out. So I'd just pick like maybe pick this one and this one. Okay. So the ordered pairs there would be 0, 4 for this guy. And then for this guy, it'd be 1, 9. Okay. So then I plot those 2 points on the XY plane. And then have to go up to 9. Okay, so 0, 4, 0, don't move, and then go up 4, and then put a point there, and then 1, 9. So 1, 9 is way up here. Then you just connect the points with a straight line and put little arrowheads on it. Okay. Okay. So in the software, the way you gotta do it is kind of click on the graph, and then below a bunch of little buttons are gonna pop up. You want to hit the second button there. It's called the line tool. Okay. And then you're going to pick points. So you're going to pick that first point. I picked 0, 4. Okay, so just click on there. And you can see below it says 0, 4. So you know you're on the right spot. And then you pick your second point. And I picked 1, 9. So go over 1 and then up to 9. Then click on that. And then all you have to do is kick back and check your answer. Okay, so the idea is you're creating this table, and then you're going to plot 2 points from the table, and that's going to be a visual representation of that equation, the y equals whatever, this 5x plus 4. Okay, let's try another one. Sure. So they're going to be fractions to deal with, so we might as well do one of these. 34. Y equals negative 1/2 x. And in their table, if you look at their table, usually they go -2, -1, 0, 1, 2 for the x values. So if you look up at our charts, in 26, the x values go -2, -1, 0, 1, 2. And 31, the x values go -2, -1, 0, 1, 2. But for this one, if you did that, you would end up with a bunch of crazy fractions. So what you do instead are use multiples of the denominator. So in our case, the denominator is 2. So we're going to use like 2, 4, 6, 8 if you want to. So just to keep things kind of what they call symmetric about the origin, so you have the same numbers on both sides of the origin, we're going to go -4, -2, 0, 2, 4. Okay. And then when we plug these in, we're not going to have to deal with crazy fractions. So -1/2 times -4, negative is positive. 1/2 times 4, 2 goes in the 4 2 times, so that would just be 2. And then -1/2 times -2, that will be positive 1. And then -1/2 times 0, anything times 0 is 0. -1/2 times 2 is -1. -1/2 times 4 is -2. Okay. So on my test, it's fine if you just put x, y, and put the x's in the first column, the y in the second column. But again, in the software, they're going to want you to type what they want you to type, right? So here we're going to be doing ordered pairs. So it's going to be -4, 2. And then I got -2, 1. And then I got 0, 0. And then I got parentheses 2, -1. And then I got 4, comma, -2. And then hope they're right. Yay. And then we go and graph 2 of the points. So I'll graph this guy and this guy. Okay. So I'll just go out to 3 tick marks on each arm. And 0, 0 is one of the points. And then the other point, 2, -1. And then you're just connecting the dots with a straight line, as straight as you can, and then put arrowheads on it to indicate the line goes on and on forever, is what the arrowheads tell you. Okay. A little different than what they call a line segment. A line segment wouldn't have the arrowheads and it would just stop. Okay, so anyways, I'm gonna click on the graph there. You might as well enlarge it a little bit. And then again, you hit the second button, the line tool, and then you just click on whatever points you want to use from the table. So I use 0, 0, and then 2, -1, and then check my answer and hope it's right. And yay. Okay. So another fraction one. Another fraction. So let's try this one. Again, see how they chose the x values. They're just multiples of that denominator that you see in the equation. So what is this, 36? Okay, so the equation y equals 5/3 x plus 6, and our table. Multiples of that denominator, 3. So that'd be -2 times 3 is -6. I'll go back to black. -1 times 3 is -3, and then 0, 3, 6. And then we're substituting in those values into this expression, and we'll get y, our corresponding y coordinate. So it'd be 5/3 times -6 plus 6. 3 goes in the -6 2 times. Right? And then 2 times 5 is -10. -6, negative. There's a positive and then a negative, so it's negative. And then plus 6 is -4. Okay. So then we got 5/3 times -3. And think of it as -3/1 if you wish. So the 3's will cancel, and I'll get 5 times -1 all over 1. So that would be -5. And that, whoops, I forgot the plus 6. Plus 6. That'll be +1. Plugging in 0, I have 5/3 times 0 plus 6. That'll be 0 plus 6, which is 6. I have 5/3 times 3 plus 6. So here the 3's cancel. And then I'll just have 5 plus 6, which is 11. And then 5/3 times 6 plus 6. 3 goes in the 6 2 times, and then 2 times 5 is 10. Okay, I'm going to pick these 2 points to plot. So I go to my XY plane, and I'm going to go, looks like I need to go negative, I need to go out to 6 at least. 1, 2, 3, 4, 5, 6. 6, 1, 2, 3, 4, 5, 6. Okay, so the first point, 1, -3, or sorry, -3, 1. So -3 left, and then go up 1. And then the second point, 0, 6. 1, 2, don't move, and then go up 6. 1, 2, 3, 4, 5, 6. And then connect the dots. Put arrowheads on it, and you're good to go. Okay. And the software then, let's zip through and pop these all in. So -6, -4. -3, 1. 0, 6. 3, 11. 6, 16. Check those answers, and then plot the character. So I'm going to click to enlarge it. Oh, that helps. And then you can, so there's a little button that says click to enlarge over there. You can also hit this button for that. There's a little magnifying glass with a plus or minus in it, so you could do that to make it big or small. So if you just really make it really big, or you could go to the left here and there underneath the table, there's a click to enlarge button. I don't know what the difference would be, but okay, so again, it's the second button that you use, and then I'm going to plot the same points. So -3, 1, and then I'm going to pick 0, 6. There it is. And then hit save, checking through. Yay. Okay, this is just another one with a fraction. More fractions, so you can get a lot of practice multiplying fractions. I think this one, your ordered pairs are probably going to be fractions, unfortunately. So what is 39? Y equals x plus 13 halves. Okay, so my table, I'm just going to go -2, -1, 0, 1, 2. Okay, so to do this, I need a common denominator, and it's going to be a denominator of 2, right? So -2 is the same as -2 over 1. It can multiply top and bottom by 2. So we have -4 halves plus 13 halves, which is 9 halves. For plotting purposes, you may want to write 4.5. The software is fine with 9 halves. The second one, -1 plus 13 halves, is the same as, well, -1's the same as -1 over 1, and you can multiply top and bottom by 2. So you get -2 over 2 plus 13 over 2. That one's 11 halves, which is 5.5. The next, plug in 0. So you get 0 plus 13 halves is 13 halves, which is 6.5. And then you kind of see patterns after a while. It's going 4.5, 5.5, 6.5. This will be 7.5. This will be 8.5. You just do educated guesses. Let's try this point and this point. So I'm going to have to go out to 6.5 or 7. 6, 7. 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so -1, I'm at 5.5. 1, 2, 3, 4, 5, and then a little bit in between 5 and 6. And then at 0, I'm at 6.5. So 0, don't move, go up 1, 2, 3, 4, 5, 6.5. Connect the dots, put arrowheads on the guy, and there's your line. Likewise, you put it on the computer. Let's see if it'll handle decimals. -2, 4.5. Whoops. -2, 4.5. -1. Oops, in parentheses, of course. -1, 5.5. And I put in too many parentheses, so I'll go over here and cancel that. 0, 6.5. 1, 7.5. 5. And then 2, 8.5. And then we cross our fingers and hope it works. Yay. And then we go over to graph the thing. I'm just going to do it right here. Hit the second button for the graphing tool. I'll do, what did I say, -1 and 5.5. So there's -1. Down below you can see the coordinate that you're on. -1 and then 5.5. There it is. And then 0, 6.5. 0, 6.5. Checking through. Yay! All right. These are then kind of interpretation problems. So later on we'll be playing a little bit with these things called parabolas, which are awesome for modeling the motion of objects on the planet, right? So if you throw something across your front lawn, it'll go up and then back down in a parabolic shape. I was talking to somebody who was shooting guns for a living there, and he said that all bullets you have to kind of take into consideration gravity, right? Gravity will pull bullets down to the ground. So when you shoot, you kind of want to aim up a little bit. I think that was his point. I'm not a marksman or anything. I don't even shoot guns, to be honest, but I think that's right. Anyways, a football is thrown by a quarterback to a receiver. The points in the figure show the height of the football in feet above the ground in terms of distance in yards. Distance being from the quarterback. So find the coordinates of point A, then interpret the coordinates as you will. So I'm going to zoom in a little bit so you can see the coordinate better. So it looks like it's not sure what the tick marks are on the bottom, right? Maybe it's going by fives, maybe it's going by ones. 1, 2, 3, 4, 5. So that don't seem right. 5, 10, 15. That don't seem right. Anyways, what do they want? The coordinates of point A. Oh, they're going by threes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That makes sense. Just take the 15 and divide it by the number of tick marks, I guess. 1, 2, 3, 4, 5. 15 divided by 5 is 3. Okay, so anyways, looks like A is at 3, 7. Okay, so I'll type in 3, 7. Sure, yeah. The football field. Okay, so one thing to note in this problem then are the x. What do the x and y? What do the x and y's represent? So problem 40, you have this chart, and it kind of looks like this. So these tick marks on the y-axis are representing the height of the football. So you can literally write that in. Kind of have to write sideways height of the football. And then the tick marks on the bottom represent the distance from the quarterback. Okay, so I kind of have to then say, okay, what does this point B, this 3, or sorry, it's point A, this 3, 7 represent? So the x coordinate is that the tick marks on the x-axis. That's the distance from the quarterback, right? And then the y coordinate is the height of the football. So when the football is 3 units, I guess, is it feet? No, yards. So when the football is 3 yards from the quarterback, so when football is 3 yards from the quarterback, the football will be 7 yards above the ground. You may have to think about, which is the height of the football, which is the distance from the quarterback. But if you think about the kind of the first coordinate, the coordinate that's on the y-axis, its position is kind of like at 0, 5.5. So initially, when the football has not been thrown, the distance from the quarterback would be 0. So it makes more sense that kind of you wouldn't have 5.5, 0. So you would not start with the football 5.5 feet or yards, whichever units are using, away from the quarterback, and then the height is 0. So you kind of have to use your brain a little bit. So initially, the football is 0 units away from the quarterback. I don't know what the units are. I don't want to confuse it. I think this is yards, and then the position above the ground is in feet. Yeah. So back up here, there should be 7 feet. But if you look at this first ordered pair, which we're going to call the y-intercept lately, this would indicate that when the football is 0 yards from the quarterback, the football is 5.5 feet above the ground, which kind of makes sense, right? Because a quarterback would be, he would have the football about 5.5 feet above the ground when he throws it. Okay, so anyways, the football is about 7, in this problem, set at the point A, 7 feet above the ground when it's 3 yards from the quarterback. Okay, and the same problem here, except now they want point D, I guess. So that's located at 10, 11. No, just at 11. 10 and then 11, comma, looks like 11.5 or something. Oh, they give you, okay, so that's that. And it's the same kind of, oh, no, so this one is a different one then. They want to know what the maximum height is. So again, if the football's height above the ground is the y-axis, the maximum height is going to be the top of that, kind of looks like a blue hill. So way at the top there, it looks like it's like about 12.5 maybe. So you just have to guesstimate these answers a bit. I hope it's right. And then it looks like it's happening at maybe in between 7 and 8, maybe 7.5 is the distance away from the quarterback when the football is at its height. And I'm just guessing at those. Here, what do they want? They want kind of a chart thingamajig. So the chart in 1960 is chicken consumption, and in 1960 it's 22 pounds. Then increased by 0.5 per year from 1960 to 2005. Give me a nice little equation. Okay, so let's just make sure we get kind of the conceptual idea down. C is the chicken consumption value. Per capita, I guess that's per 100 people or something. And then N is the number of years after 1960. It looks like just from the data chart that the amount of chicken consumption is going up. But they want you to make a table, and maybe that's just a list of ordered pairs using this formula. So C equals 0.5 N plus 22. And then they want N and C. So it's a little weird because they're not using X and Y, but don't let that fool you. It's just the same kind of problem as before. So they want 0, 10, 20, 30, and then 40. So plugging in 0, you got 0.5 times 0 plus 22, that's just 22. 0.5 times 10 is 5 plus 22, that would be 27. 0.5 times 20 is 10 plus 22, so that'll be 32. Looks like it's going up by 5 every time, right? So 22, 27, 32, this will be 37, and then 42. So this will be we're very popular with the spam calls today. 27, 32, 37, and then 42. Give an answer there. Yay. Graph the formula in the rectangular coordinate system. Okay. Oh, they just want you to plot. Okay, so at 0, it's 22. So you're just kind of looking for the one that starts at 22. Yeah, this is 10, 20. No, there's no way, right? 1, 2, 3, 4. Okay, so maybe it's this one. So it's 10, 20, and you know it's going up by 5 every time. So it has to be this part B here. instead, because part C it's going down every time. So that looks good. Continue. And then they want you to use the graph. I would advise not to use the graph because you might get it wrong if you look at the graph, because it's, I would say just plug in the value. So the end value they're going to want for this one, the consumption in 2015. So you're basically subtract away 1960, 5, 1. I believe that'll be, really? Oh, that's a 6. It's not a 0, Dave. So 5. Okay, so that would be 5, and then this would be 8. 855 is the, I can't subtract anymore. It's 55. All right, so you're plugging 55 into the formula, so C will equal 0.5 times 55 plus 22. I'm going to need a calculator, sadly enough. I was hoping to avoid this eventuality, but here we are. 0.5 times 55 equals plus 22. And then they want you to round to the nearest integer. So that's the nearest whole number. So in this case, that will be 50. And so 50 pounds of chicken. Are we done? No, we have more. Oh, then they just want, now they want you to use the formula. So you get the same answer because I used the formula the first time. But I mean, the graph is, what? I can't believe I got it. I must have made them. Oh, it's a decimal this time. They want a decimal. So that's the issue. All right, so who did we say? 45.5. 5. And then you should be good. Still not good. What was the stupid decimal? 49.5. All right, well, that will do it. Gotta read directions, folks. Okay, so I hope that helps. I know I kind of breezed through some of those, but I hope that helps. Okay, thank you for watching, and as usual, I will see you next time.